Good morning, fifth grade online learners. Welcome to March 29th, 2021, fifth grade science. Using electricity is our lesson today. And we're just going to read from the book, and I have some volunteers that are going to come up and also read. Um, they're going to do their best to speak clearly and loudly so that you can hear. If you're having trouble, hopefully you have a book at home that you can read, starting on page F124. And if not, your study guides are always a great resource. There is no quiz this week. The quiz is after Easter break. So this week we have um, two journal entries. Next week, two journal entries, and then the quiz. Because there's only 3 days each week. Hannah.
Well, if we have two journal entries this week and two next week, so that'll be for four, and technically only we have Monday off.
We have Monday and Tuesday off next week. So you're going to end up with 4 points for one lesson. Usually we have 3 points, but this time you'll have 4 points for one lesson split up over 2 weeks. Okay, using electricity, guys. And here's some interesting things about electricity, guys. It has really made our life so much easier. We have lights in this room. We have ways to communicate. We have energy, and it's all because people pursued and discovered electricity and how to use it. Electrical energy is transformed into light, mechanical energy, and thermal energy for a variety of uses. Energy transformations. One of the first popular devices was the telegraph machine. To send messages, a telegraph operator used a simple switch called a key. The switch was connected to a circuit that spanned long distances. Pressing down on the switch closed the circuit temporarily. At the other end, some receivers used a pointer that moved back and forth, converting the electrical energy to kinetic energy. Other receivers used a buzzer. Both types of receivers used electromagnets to convert the electrical energy into another form. The buzzer made its sound because an electromagnet rapidly vibrated a piece of metal against another material. The pointer was also operated by an electromagnet. And what am I talking about? Well, if you look at this wooden device here, that is a telegraph. And it says the telegraph key, you would press it and it would make beeping noises like beep, 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 beep. And that, I know some people are laughing, but that could be translated into letters, which could be translated into words. And the only way to communicate between these two devices was to run a long wire. So imagine you're Abraham Lincoln, you're the president, and the Civil War is going on, and you have to communicate with your generals, and they have to tell you what's happening. You would have to run a telegraph cable from Washington, D.C., from the White House, to wherever the battlefield is. And that could be hundreds of miles away. But they did it, and the president had up-to-date information almost instantly of what's happening. That's very valuable because he's calling the shots. He's making decisions. So telegraphs were used a lot right around the Civil War era. And eventually now we have cell phones. We don't even have to connect a wire from one device to another. But cell phones depend on electricity also. So without electricity, guys, some people would argue our life would be so different, and it could be quite possibly the best invention of the last century. Okay? Some people argue it might have been plumbing or something else, but without electricity, how do we communicate? All right, so we have some volunteers, and this is our next page, and they're going to come up and talk to you about electricity for lights, hair dryers, and circular saws. So next up is Evelyn. Evelyn, come on up. You can have a seat or you can stand and read the next page.
Look at the headlamp the student pictured on the right is wearing. It consists of a simple series circuit made from a battery, a switch, and a light bulb. The filament and a light bulb resist the flow of current. As a result, the filament heats up and gives off light. Electrical energy changes into light and thermal energy. The hairdryer also converts electrical energy into thermal energy. Coils of thin wire inside the hairdryer resist the electric current. The coils are made of an or mixture of nickel and this material has very high resistance. The coils produce a lot of thermal energy as current flows through them. A fan that converts electrical energy into mechanical kinetic energy pushes the hot air out of the hairdryer. Switches on the hairdryer allow the user to vary the temperature and the airflow. The saw also converts electrical energy into mechanical energy, kinetic energy. It has a switch for varying the speed of the saw. The switch works by changing the voltage to the electric motor in the saw. When pushed in a little, less voltage is applied to the motor, less current flows, and the motor runs at a lower speed. When the switch is pushed all the way, the full voltage is applied. More current flows and the motor runs faster.
Good job, Evelyn. Nice and clear. We were able to understand you. Danielle, on down. You're the next contestant on The Science is Right.
An electric motor changes electrical energy into mechanical kinetic energy. To do this, a motor uses both an electromagnet and a
I see. Permanent.
Oh. And a permanent magnet. Thanks to clever construction, the poles of electromagnet constantly exchanges positions, which allows it to keep spinning. The diagram shows the parts of a DC motor, meaning a motor that runs on direct current only. Here's how it works. The axle holds a kind of frame called a armature. An armature includes a set of coils wound around a metal rod. Also attached to the axle is the communicator, which is a pair of springy metal pieces with small gaps between them. The communicator is connected to the coils of the armature. Resting on the communicator are brushes which are connected to the motor's power supply. When current is supplied to the motor, the current flows through the brushes, the communicator, and the coils of the armature. This makes the armature act an electromagnet. The poles are permanent magnet repel like poles of the electromagnet. This causes the armature to rotate half a turn, bringing the like poles closer together. The armature continues to rotate because of the gaps in the communicator. The gaps were positioned where the magnets attract each other and would stop the motion. The gaps break the circuit, briefly turning the electromagnet off. When the communicator contacts the brushes again, its two metal pieces receive the opposite polarity. These reverses the current. These reverses the current through the coils, which reverses the poles of the electromagnet. The armature completes the other half. I think I read that right.
Good job, Danielle. And last but not least is Maddie, and we're kind of running short on time, but we're going to try to squeeze Maddie in here because she's our great volunteer. Come on up, Maddie.
Well, Large generators at power plants produce the electricity that travels to your community. This often is a long journey, sometimes covering hundreds of kilometers. Electric power can be lost to heat. This is why long distance power lines carry electricity at low current but very high voltage, as high as 500,000 volts or more. Such wires typically are strung high above the ground, as they are dangerous if touched or disturbed. To raise or lower voltage power, companies use devices called transformers. A step-up transformer increases the voltage. This is done as electricity leaves the power plant. A step-down transformer lowers voltage. Voltage is lowered before entering your home. If you look up at a power plant in your neighborhood, you may see a drum-shaped can. This houses a step-down transformer that reduces the voltage to 240 volts, the level that enters your home. In homes in North America, most household appliances, including televisions, lamps, and computers, run on 120 volts. However, major appliances such as water heaters, clothes dryers, and air conditioners run on 240 volts. Household circuits can be wired either to the 240 volt or the 120 volt supply.
Wow, perfect timing, and thank you to my volunteers because we are out of time. We will see you tomorrow. Thank you. Bye-bye.